So my name is William Walsh. I am one of the federal program managers for the Light Water Reactor Sustainability Program. And also on the line are Stelana Lawrence, who's at Idaho National Lab, and Tyler Westover, who's filling in for Richard Boardman, also at Idaho National Lab. And those are the technical POCs for this solicitation. So I'd just like to give a brief overview of the Light Water Reactor Sustainability Program. The overall goal is to enhance the safe, efficient, and economical performance of our nation's nuclear fleet. So in particular, the light water reactor fleet. And kind of within this goal, there are two parts. One is to enhance the economic competitiveness of the current fleet by doing two things. One, diversifying their sources of revenue beyond selling electricity to the grid and reducing costs. And then the other is to ensure the long-term performance of the structure, systems, and components of the plant. So this includes things like addressing technology obsolescence and then also managing aging materials. And so to implement those objectives, we kind of have 5 different focus areas. One, the first is plant modernization, research and development. The second is flexible plant operation and generation, risk-informed system analysis, materials research, and physical security. So within these 5 focus areas, which we call pathways, we're looking to implement these objectives of enhancing the economic competitiveness and ensuring the long-term performance. So for this solicitation, it's going to focus on the flexible plant operation and generation pathway and the risk-informed system analysis pathway. And so for flexible plant operation and generation, we're interested in increasing the revenue opportunities for the plant, so diversifying the revenue stream. And the questions we're interested in are what is technically possible, and then also what is economically sensible. And so increasing the revenue stream is going to consist of integrating the nuclear power plant with other processes that are going to require new safety assessments and licensing approaches. And that's where the risk-informed system analysis pathway comes in, aiding in that task of developing risk-informed tools and methods to assess safety and reliability of the new systems. So specifically, I'll just read part of the solicitation verbatim. We're looking for research projects that accelerate the development of control systems, data collection, processing and system diagnostics, and computational tools that enable the existing LWR power plants to be efficiently and safely integrated with process applications, and that allow nuclear power plants to provide ancillary services to the grid. So all of this is part of diversifying the revenue stream. So kind of the motivation for this work scope is that nuclear power plants are considering more flexible approaches to plant operation. This is going to require technologies that are unfamiliar and new to the current commercial nuclear power industry. And so this is going to require new operating concepts, supporting technologies, and risk assessment tools. So it's a broad work scope, and what we're seeking specifically is a consortium, which must consist of a university lead and at least one additional university collaborator. But then beyond that, the consortium can consist of additional university partners or non-university partners. And the award is for $4 million and up to 5 years. And so overall, this work scope is split into 4 different parts. The first focuses on the control systems that enable the flexible operation of the plant. So specifically, control systems that are capable of rapidly apportioning thermal and electrical power to support electricity grid technical services while optimizing plant revenue through energy arbitrage. So we want the plant to be flexible enough to respond to the fluctuating price of electricity. So since the price of electricity is varying over time, one way to increase revenue is to sell electricity to the grid when the price is high, and then use energy for other purposes, or store it for sale at a later date if the price happens to be low. So operating in this way is going to require new tasks performed by the plant operators. And so we're looking for design and testing of new operator task panels with human factors that ensure reliable human performance and efficient hybrid operations. And so also as part of these control systems, we'll need to develop standards and protocol for grid to plant data links, so data transfer between the grid and the plant. So this is going to allow plants to communicate directly with the regional transmission and balancing authorities, and enable the plants to participate in capacity markets and provide other ancillary services to the grid. Part 2 of the scope focuses on developing computational tools and simulators. So these could be general or plant-specific LWR simulators, and they could be used to help design, test, and optimize dynamic thermal energy extraction and delivery and electricity dispatch. So we're looking for a few different types of tools. One, full scope simulators of the plant used to optimize energy extraction while remaining within the operating basis of the plant license. Second, reduced order models of integrated systems, of the integrated system, used to accelerate the development of human factors. So again, how are operators going to perform on this new equipment? And then finally, computational models that simulate physical unit operations at the plant. So how is the plant going to respond to initiating events given the addition of these new modules and processes that are being integrated into the system? So an example of this could be, do these new modules affect the thermal hydraulic performance of the plant systems? All right, part 3 of the scope focuses on the extension of the legacy probabilistic risk assessment tools, specifically to new initiating events that could be introduced by new grid-to-plant process control coupling, or also plant-to-hybrid process controls coupling. So interaction between the grid and the plant, and also interaction between the plant and these new modules. So these introduce the possibility of new initiating events. So a couple examples that we're interested in would be a plant that can flexibly apportion energy between the grid and thermal and electrical power to a hydrogen production plant. What new events might arise and what risks are posed to the safety and operation of the plant. Another possible hybrid operation is a plant that stores thermal energy for power arbitrage on the grid. And we'd like tools where the power dynamics of power transmission are included in potential loss of load events. And then the last part of the scope is concerned with the development and demonstration of operating concepts using smart valve flow controllers, smart instrumentation, data links, and data analytics for hybrid plant operations. So part of this new system will be a system of thermal flow loops with multiple outputs and inputs. So each potentially serving different processes. So we're looking for a couple things related to this system. One, approaches that combine the analog instruments and controls that are still in use at some nuclear power plants with modern digital instruments and controls that will be used for these additional modules for thermal and electrical power dispatch to external users. The design and testing of smart valves and valve alignments in this system, data management procedures and standardized analysis techniques that will enable operators to track the state of the system, and then can also be used to automatically adjust process conditions. Instrumentation and data analytics that monitor the health of the overall system, And then finally, approaches to all of this that provide inherent cybersecurity and ensure reliable operation of the system. So in general, this is all about incorporating new ways of diversifying revenue into the nuclear power plant systems. And at this point, I can end the presentation and open up for questions.
Okay, I have unmuted Tyler, and Svetlana should be able to open up her microphone if she wants to help answer questions. Let's see, the first question we have, so far the only question. So if anybody else has questions, please go ahead and type them into the question answer portion of the GoToWebinar application. First question, is maintenance optimization part of this IRP?
I think that might be a question for Lana.
I don't see it being part of this work, this particular proposal, but it could be important. So I'm not quite yet prepared to answer this question because maintenance optimization would depend on the risk parameters that you gain from your PRA model. And by introducing new modes of operation of the plant, you're changing the PRA model and you're changing your risk parameters. So the optimization of maintenance is not part of it, but maintenance should be considered how it is affected by this new mode of plant operation.
I got a comment. This is Tyler, a comment. And that is a major complexity of the concept of design. You have this steam clean, probably being extracted the power plant to use a possibly hydrogen plant. A steam cleaning out is easy to deal with. But once it's returned again in the plant, as a condensate, that return line is very complicated. I need probably return in multiple points. Be a point in a heater system at various different heaters. Now return to operate without losing efficiency and losing that operating ability. Make that work because the human factor is operating in monitor those return lines. There are multiple lines, locations. If one line fails, that can cause plant issues. It could have to be responded, identified, and then mitigate quickly. And so the human factor is the operators to manage these new lines, traction lines, return lines. That's a major drain on the operators, potentially how to function, the ability to respond to plant needs. So a lot of designers that do a good design is simple enough but adequate, and so operators can manage that design effectively in different procedures.
Okay, thank you. Next question. Does a proposal need to cover all 4 of the focuses or just include 1 or more?
I think overall, I can try to answer this question. I think overall, all of the applications together should cover all 4 of the focuses, but each partner on the consortium may only address part of it. Maybe that's maybe someone else can add a little bit more to that.
Sure, Bill, this is Jason. So it's ensuring that there's a scope of work matching with the funding level. So, if there's a lot of detail in this particular area, might use the funding proposed versus spreading the funding out to multiple areas. I think we anticipate that more than one will be covered by this funding level, considering the format.
Okay, thanks. Next question. Will the electrical grid, microgrid also be covered in this call?
I'll take a stab at that one. The emphasis here is really on the plant.
Okay, it doesn't look like we have any more questions for this work scope.